unless the planet began smaller and got bigger. We are now a few 100 million years ago. Let's go back hundreds of millions of years further. I cannot say that all these movements are exactly right. They are the very best I can provide, working along a very strict set of guidelines. All the upper dark plates remain at the exact same size throughout. They don't stretch, squish, they don't rotate as if floating. Plates shift with growth. All portions follow sensible rules of cause and effect movement. These are tectonic movements, and within the tectonic movements there is no subduction. Tectonic movement without subduction. And bam, we've closed the upper plate. Mars is less than 50% smaller than it was, and about 1/4 the volume. To make its size more clear, here is our moon for a size comparison. In fact, at this size, if we take the reddish cast away, Mars kind of looks like our moon. We're going to go forward in time to reveal the lower tectonic plates. While the planet Mars grows, note that none of the dark tectonic plates change in size. They slide apart. You ever take a hunk of slate and wrap it to separate the levels? That's what happens when plates shift, and that's how we get earthquakes.
Okay, that takes care of Mars. We have one more video to share with you, and this is going to be of a distant relative in relationship with Jupiter.
This is Europa, a moon of Jupiter. It has a most incredible surface. Speculation as to its surface composition has included ice, slushy ice, and, well, whatever. Doesn't look like ice to me. I don't think ice pushes up ridges like these, but there you go. Whatever it is, the mineral cracks and spreads as Europa grows. This is the latest photo that NASA has supplied to us on the internet. See that gash down the middle? It's a tectonic spread. Actually, NASA seems to think so too, which is, yes, a surprise. Let me show you why a spread is the only proper description for what you see here. First, some small cracks happen more currently than the big spread, so we'll put X's on them to mark them. We know they're newer because they invaded the spread here, 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 and here. The rest of the cracks are older than the spread. I've asked Zia to cut up one side of the spread. Thanks, Z. Now we'll move this side over to the other side and swing the bottom over. Good. All these sides match exactly, so much so that the line that defines the crack disappears. I think anyone can see this clearly. Here's another crack. The land spread up to the right, so let's bring it down and left. There. I believe this is ongoing eruptive silicate growth from the moon's inside. If this isn't growth of this moon, where is this material going? Maybe it's subducting. Kidding. Can you spot the break now? No, it's here. Isn't that incredible? The surface area here has been reduced by 1/4 or more, and it happens all over this moon. When I saw this photo, I bet myself that the area on the lower right-hand side matched its opposite surface on the upper left-hand side. So let's try it. You can do this experiment yourself using the same photos from NASA. This moon, just like all moons and all planets and all suns and our whole universe, is growing.